There are quite a few things to program in this game, so we'll start by decomposing it. A natural way to break it down in smaller parts is by identifying the different objects that we need to program. We have the broom, the zombie, the flower, and the stage. Let's decompose the program for each of these further. We'll start with the broom. We want to be able to move the broom with our mouse, so the broom should always be moving to the mouse position. Its sweeping behavior will be programmed within the zombie. The broom should also be initialized at the beginning of the game. This involves placing it in the center and giving instructions to the user. We could have chosen any character to give the instructions, but the broom is a natural choice, as it is the main character with which the user controls the game. It is also worth mentioning that no zombie should appear while the broom is giving the instructions, so as to keep things fair for the players. We should keep this in mind when designing the code for the zombie. Now let's do just that. How many zombies should we have? We want an unlimited number of zombies throughout the game, but how can we achieve this? With the use of clones, of course. So we first initialize our zombie, and then we keep creating zombie clones regularly. But how often do we create new clones? To answer this question, we need to consider our game requirements. We want to have different difficulty levels, so we can make the zombies appear from time to time, which may be configurable. For a difficult game, the time between the appearance of zombies will be small, while for an easy game, this time will be bigger. To keep track of the time between the creation of zombies, and to be able to modify it, we'll need a variable. Apart from this variable, we'll need another one for the score. Both these variables will be set at the initialization of the zombie, which also involves waiting for a bit so as to give the player enough time to read the instructions. Now, let's design the zombie behavior when it starts as a clone. It is first located on the stage, and then it keeps moving to the left, checking whether it is touching the broom, the flower, or whether it's reached the house. Whenever it touches the broom, a sound is played, the game score is increased, and the zombie will go back. Well, whenever it touches the flower, it will hold for a few seconds, and that's it. Once the zombie reaches the house, the game is over. We'll specify later on what it means for the game to be over. Now, let's think a little bit more about the zombie's movement. How fast should the zombie clones move? We could specify that they move, say, 10 steps every time. Alternatively, to make the game more fun and challenging, we can specify that every 5 seconds the zombies increase their speed. To capture this, we'll need a variable for the zombie speed, that is, for the number of steps to move. When should we first set its value, and when should it be changed? Is this something that we should take care within the code for the clones, or within the code for the actual zombie sprite? We've mentioned that the zombie speed should increase every 5 seconds and affect all the clones created. This gives us a hint that the speed should be dealt with inside the code for the sprite itself. We can initialize it at the zombie initialization, but where should we specify that it increases every 5 seconds? This needs to be defined in a separate script that runs at the same time with this one.
OT. Why do we need another script? Couldn't we just include this in our existing script for the zombie behavior?
I'm afraid not, Cody. Let me explain why. If we did go for this approach, then this would mean that the following process would repeat forever. First a clone is created, then we wait for some time between zombies, next we wait for another 5 seconds, and finally the speed would increase. But this is not what we want. So we want the two processes to run simultaneously. In computer science, we say they are concurrent processes.
Okay, thanks.
Concurrency is very common in everyday life. Chefs in restaurants, for instance, tend to prepare several dishes at the same time. They may be boiling some potatoes, grilling a steak, and roasting some vegetables, all simultaneously. And if we look at the bigger picture in a restaurant, the chef's behavior is concurrent with that of the waiters and other members of staff. They're all working at the same time. Concurrency is a very important concept in computer science as well. In Scratch, it is very easy to create concurrent programs. And if you think about it, many of the programs that we've been creating so far are actually concurrent. For example, in the Pong game, the programs for the ball and the paddle run at the same time. They're concurrent. Great! We're done with the design of the zombie behavior. Now let's have a look at the flower. When the game begins, we want to have several flowers in the garden, say between 3 and 10, where the exact number is randomly chosen. Good. Now, what will the flower behavior be when it starts as a clone? It will involve placing it somewhere on the screen and having the flower repeatedly change costume so it looks even cuter. This will repeat happening until a zombie touches it, at which point the flower will be deleted. And how about our stage? We've designed 2 backdrops for the stage. The garden backdrop will be used when the game begins, and once the game is over, we'll switch to the backdrop that announces this. Now, what else happens when the game is over? All scripts should stop execution. This can be programmed within the code for the stage. Good. We've decomposed our program and we've come up with a detailed design of our code. In the next video, we'll start building our game in Scratch.